everyone, I am going to explain question number 11th of exercise 2.1 of class 12th. The question is, if tan inverse x plus tan inverse y plus tan inverse z is equal to pi by 2, then prove that xy plus yz plus zx is equal to 1. So we'll start by the given thing. Now here you can see directly we can use the formula, that is tan inverse x plus tan inverse y plus tan inverse z is equal to tan inverse x plus y plus z minus xyz upon 1 minus xy minus yz minus zx. So in the left hand side I directly use the formula, and this pi by 2 I wrote as it is. Now in next step, this tan inverse, when we'll shift here, it becomes tan pi by 2. Now in next step, this left hand side we wrote as it is. Tan pi by 2, as you know, it's infinity. So we got here infinity. Now you know that how infinity we used to get. Infinity we used to obtain if any number is divided by 0. So when we'll compare it, we get that denominator is equal to 0, because infinity is only achieved if denominator is 0. So when we'll compare it, we'll get that 1 minus xy minus yz minus zx is equal to 0. We wrote this. We'll avoid here the numerator because the required thing in the question we will achieve by the denominator itself. That's why we will pick only the required thing, that is denominator equal to 0. You can avoid this step. After this directly you can write this also. This I wrote only to explain you why we got denominator equal to 0. Now we'll shift all these negative terms in the other side, so that will give us positive xy plus yz plus zx equal to 1. That is our required thing in the question. Hence this question is completed. Now we'll move to the question number 12 of same exercise. So exercise is 2.1, question number 12. The question is, if 1 upon 2 sin inverse 2x upon 1 plus x square plus 1 upon 2 cos inverse 1 minus y square upon 1 plus y square and plus 1 upon 3 tan inverse 3z minus z cube upon 1 minus 3z square is equal to 5y, then we have to prove this. So students, you can see all terms are different here. It's not like previous question that we have all trigonometric ratios are same, so we use single formula. All are different here, and all the polynomials are also very different from each other. So we require a substitution here. So the substitutions, for substitution we'll assume x is equal to tan a. Here x is equal to tan a and y is equal to tan b and z equal to tan c. So this is our assumption. From these assumption we'll get a as, because tan will go there, so it will give us tan inverse x. In the same way, from here we'll get b is equal to tan inverse y, and from here we'll get c is equal to tan inverse z. Now students, why we assumed only in terms of tan? Because students, you can see here I wrote some formula that I just want to explain first, that why I assumed only tan. Because sin 2 theta is in tan terms, cos 2 theta is also in terms of tan, and tan 3 theta is also in terms of tan. So if we'll assume all x, y, z in terms of tan, we can relate them with the sin, cos and tan. That's why that is the hint for us that x and y and z we should assume as tan a, tan b, tan c, so that after substitution, just see I substituted here the values of x, y, z in left hand side of our question. After substitution here, instead of x tan a, just observe this properly. When you will observe it, you will find that it is in the form of sin 2 theta. So what is theta here? Theta is a here. That's why this complete term will convert to sin 2a. So why we change into sin? Because this sin and sin can remove each other. That's why. In the same way, when we'll replace y by tan b, just observe this complete step. That is the formula of cos 2 theta. That is, instead of theta we have b here, so it's a formula of cos 2b. In the same way, instead of z we assumed tan c. So wherever z is there, just replace it by tan c and tan C. So you will get this is in the form of, you just observe this complete properly, 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta is the formula of tan 3 theta. So just compare it, they are alike to each other. That's why instead of this we can use tan 3c. Now this tan inverse and tan, this cos inverse cos and sin inverse sin will cancel each other. That will give us, after cancellation, half will remain as it is, and here will remain with 2a, and here also this half will come as it is, and 2b, this 1 upon 3 as it is, and here tan and tan remove, so 3c, and this 5 pi as it is. Further, you can cancel these 2's and 3's. So you are remained with A, B, C is equal to 5, 5. Now, you just see we already calculated the values of A, B, C initially, that is tan inverse x, tan inverse y and tan inverse z. So these values of A, B, C we will replace here, that is tan inverse x, tan inverse y, tan inverse z is equal to 5 pi. This replacement we had done from the equation 1. Now you have directly formula for these three terms, that is this formula. We had used the formula here. Now tan inverse will move here and it will become tan pi, tan 5 pi, and you know students tan n pi is always 0, so that will give us 0. Now when will this denominator, when will come here, it will multiply by 0 and become 0. So we got this is equal to 0. So we'll shift this negative xyz in other side. That will give us xyz is equal to x plus y plus z is equal to xyz. That's our required answer. So in starting onwards, in this question, you just see properly the question. When you will observe the question, it should come in your mind that it is in the form of sin 2 theta, and it is in the form of cos 2 theta, and it is in the form of tan 3 theta, but only if we can have instead of x tan theta and instead of y tan theta and instead of z tan theta. That's why that will guide you that you have to do these replacements. Now we'll move to the question number 13th of the same exercise, that is exercise 2.1. 13th question, if sec inverse root 1 plus x square cosec inverse root 1 plus y square upon y plus cot inverse 1 upon z is equal to 3 pi is given to us, this is given to us, and we have to prove x plus y plus z is equal to xyz. So this question also will prove as we had proved the question number 12, same substitutions. Now we had assumed here x is equal to tan a, y is equal to tan b, and z is equal to tan c. That gave us, because this tan will go here, so it becomes tan inverse x. So from here we got a is equal to tan inverse x, and from here we got b is equal to tan inverse y, and from here we got c is equal to tan inverse z. Now these all replacements in this x, y and z we will do. So I wrote here the question, given thing, and in the given thing we will do the replacement. Instead of x I wrote here tan a, and instead of y I wrote here tan b, and instead of z we wrote here tan c. Now here, this is the formula of sec a from this identity, which is very popular identity in maths, and here also it's a identity again, that is sec b. Now this tan b, students, you know that tan theta is equal to sin upon cos theta. Now this 1 upon cos theta we can write as sec theta. So this tan b I substituted in terms of sin b and sec b, and this root 1 plus tan square b completely I replaced from this same identity, that is sec b. So I hope this is clear to you. Now cot inverse 1 upon tan c, this 1 upon tan c we can write as cot c. Now in next step, this sec and sec will remove each other, so only a will remain here, and here sec b and this sec b will cancel each other, and this 1 upon sin b we can write as cosec b, and cot will remove, and we are remain with here c. Now in next step you can see cosec and cosec will remove each other, so we are getting here only b. So finally what we got? A plus B plus C is equal to 3, 5. Now initially you might notice we already calculated the values of A, B, C, that is tan inverse X, tan inverse Y, tan inverse Z. Now instead of A, B, C, we'll write down tan inverse X plus tan inverse Y plus tan inverse Z is equal to 3 pi. Now this we had done, replacement we had done from equation 1. Now we'll use the formula on 3 terms, that is this formula we had used. Now this tan inverse came here, and you know that this tan n pi is 0, that's why tan 3 pi is also 0. This denominator is in division, so it will come here and it will multiply by 0 and gave us 0. So here this is negative terms will shifted here, so it got positive. That's why we got here x plus y plus z is equal to x, y, z. Hence this result is proved. Thank you.